Hi there! In this video series, I will explain the piecewise function. We will learn how to find equations of the given graph, determining domains, and graphing piecewise functions given a set of equations. So first I want us to define what a piecewise function is and learn how to determine the equations. Sometimes a function is defined by different equations in different regions of the domain. For example, in this graph here, you have this region of the domain, which is -2 going all the way to -infinity, and that would be defined by the equation that describes the graph 1 here. The equation that describes graph 2 would only be applicable between -2 and +1. The equation that will describe graph 3 here, I hope you can see number 3 right there, is only applicable in that little tiny domain region which is marked in green. And that's between 1 and 2. The equation that will define graph 4, and you see the arrow here, which means it's going all the way towards +infinity, is only defined in this domain region here, going all the way to +infinity. And I notice that the shape of the graph is all linear. So I know I can use y equals mx plus b, and if I can only find 2 points on each of these graphs, I'd be able to figure out my slope, my y-intercept, and get the whole equation, provided I make the restrictions at the very end. So the first graph here, I used -4, 2 and 2, 0 as the 2 points, and worked out my slope using y minus y2 divided by x1 minus x2, 2 minus 0, which is the y points for both, and then -4 minus -2, which becomes -4 plus 2, -2, and the slope becomes -1. In the equation y equals mx plus b, I used the slope right here. This is actually -1. Negative's kind of hiding behind the equal sign. Using this point here, -2, 0, 0 for y, -2 for x, we can figure out the b. And we have our equation y equals -1x plus b. That's -2, provided I define my domain, which is -infinity all the way to 2. This is a closed circle, so we need to use a square parentheses. You can also write it as -infinity less than x less than equal to -2. You always want to say less than equal to if it's closed. You don't need to if it's open. And the second equation here did the same thing. Used 1, 4 and -2, 0 as my 2 points to figure out my slope. So it'll be 4 minus 0 divided by 1 minus -2, and the slope became 4/3. Y equals mx plus b again. Using this point here, 4 for y, 1 for x, 4/3 for the slope, we can figure out the b, and finally we get the equation 4/3 x plus 8/3. Big deal here, again, is defining your domain. That equation is only applicable in this region right here, -2 to 1. -2 to 1. Both of them are closed circle, so I will put a square parentheses. Or you can go -2 less than x less than equal to x less than equal to 1. In that little green region, there is this equation right there, that there's 2 clear points, 1, 4, and this one is 2, -3. So using these 2 points, similarly we can find the slope, and I used 1, 4 again, so 4 for y, 1 for x, -7 for the slope, and you calculate the b. 7 plus 4 is 11, so this is your equation, y equals -7x plus 11. Again, must always define your domain for piecewise functions, and this is between 1 and 2. Again, this is closed circle, so it will be heart parentheses here. The final equation is line number 4. The slope you know is 0, so the equation is really simple. The y-intercept is -3, so it's basically y equals -3. And the domain is the purple one here, and it's going all the way out to +infinity. Starting out, you can see that it is starting out at 2, so 2 going to +infinity. Or you can write down 2 less than equal to x less than +infinity. All right, very good. Thank you. I shall see you in my next video. Goodbye.